Today's pseudocode is a program that reads numbers from the user, counts the number of negative values, counts the number of positive values, and prints those results to the console. The program pseudocode has been distributed, and we will make some modifications to it when we are finished if we have time. First thing we do, as always, then is create a new project. We'll call the project looping count positives and negatives. And inside the source folder I will create a package, as I always do. Inside the package we'll create a class. Just to shake it up a little bit, I'll call the class count positives and negatives. Make sure I have a main. There's my starting point. Inside the pseudocode, referring to the main method, declare two integers, positive count, negative count. There's no reason not to put those two on the same line. We could declare them separately, but it would have no effect on the program. This tightens it up just a little bit. Assign these the value 0. We could also tighten it up even more by putting the assignment statements inside the declaration statements, and then I'm just going to take out these two other lines of code. Now I have a declaration and an initialization all consolidated into one statement. Very common practice, not a problem to do that. Continuing on with the pseudocode, declare input as integer. I'll just int input. I could have tacked that on to the same line as up above, but since it's a different name, we'll put it on a different line. Nothing but a style issue. The next thing we do is print. This program counts negative and positive integers. System.out print line. This program counts negative and positive integers, semicolon, and then another prompt, enter a series of integers or 0 to quit. Then we drop into a loop. The pseudocode says loop forever. I'll add that comment to my code. A good infinite loop is while true. True never becomes false. When I press enter, Eclipse fills in the closing curly brace, which is always nice. Now I've got an infinite loop. Whatever code I put in there will run until the machine turns off. But I'm going to build in a backdoor way to break out of the loop by using a break statement later on. Read from the keyboard. I've got a problem because I haven't declared in, which is what we typically use as our scanner variable. And I'll just go up above the loop and I'll say scanner in equals new scanner system.in. That'll solve the problem of having declared in. But now I've got another problem because I don't know where scanner comes from. It's a class that Java doesn't recognize, but Eclipse provides me with a solution. Import scanner, the very first fix suggested by Eclipse. That drags in java.util.scanner and solves the problem of scanner not being defined. After I read in from the keyboard into my input variable, I need an if statement. If input equal 0, I'm supposed to exit the loop according to the pseudocode, and we do that with a break statement. There's my backdoor to break out of that infinite loop. Now, since there's only one statement there to be executed as part of the true clause, I'm not going to put braces around it, and I'm not even going to put it on the next line. I'm just going to put it all on the same line. I could, if I wanted to, open a curly brace there and close the curly brace there. Another possible style of programming. Or I could go whole hog and break everything on its own line. Now it takes 3 lines of code to do what I did in 1 line of code. It's a matter of taste and style. They all work the same way. I'm going to go back to what I had. Depending on where you end up working, depending on the coding standards that you're required to follow, that may be acceptable or it may not. I'm okay with that. It's a fairly standard construct. Okay, if the user did not type in 0, then we continue on and we do another if input is greater than 0. And again, we've got 1 line of code to be executed, and we have the option of using the braces or not. Positive count plus plus. There's a shorthand way of incrementing the variable by 1. Else, if it's not positive, it must be negative because we know it's not 0 if we make it this far. Negative count plus plus. That brings me to the end of my while loop. Sometimes we document the end of a loop by adding a comment that mirrors the beginning of the loop. That way when you see that curly brace, you know what it matches up with. And this loop is very tiny. It's easy to see where the opening of the loop is as far as in matching it up with the closing, but it's a nice little style touch sometimes to put that comment in there. And then after we exit the loop, we need a couple of print statements. System.out.println you entered so many positive integers. We'll do the same thing for the negative side. I'm going to copy and paste this and edit it. It's just a little bit easier. I forgot the word positive. And there's my pseudocode implemented in Java. Of course, it could look different. You could use a for loop. Different ways to implement pseudocode. There are many right answers. And I think I'm ready to test now. I don't see any squiggles that are hard stopping. And I will save it in case something goes horribly wrong, which it probably won't. Click on Run. There's my prompt. Enter a series of integers. Now I can enter one number on a line and press enter, number enter, or I can just put all of them on the same line separated by one or more spaces. And it will work the same way. The program doesn't know how the data is being presented, it just knows that they're separated by spaces. And the last number would be a 0, and I would expect to get 3 for the positive count and 3 for the negative count. And I do. At first blush, then this seems to be correct. It seems to work. Not a very good test because the same number was presented for positive and negative. Let's do another test. Now I would expect to get 1 for the positive count and 3 for the negative count. That works. Let's try a boundary condition. Let's put in 0 as our very first number, and that will cause neither positive nor negative counters to increase. And that looks like that works. With basic testing then, it seems that we have implemented the pseudocode correctly.